Good morning, everyone. I'm audible? Shrikant sir?
Yes, madam.
Okay. So welcome to the D9 session 1. I hope you're all enjoying the session. We have our Ramesh sir with us from Vellore Institute of Technology. Welcome to the session. What's the part? Sir, there's some background noise. Can you please check it out? Sir.
From my end, madam.
A little, yeah. I mean, your voice is not audible for us.
Now is clear, madam?
Yes, sir, it is clear.
Yes, madam. Thank you.
So today we are going to have a hands-on experience of MATLAB programming and how this MATLAB programming helps us analyze the characteristics of materials. So over to Ramesh, sir.
Thank you, madam. Yeah, good morning to all of you. Today we are going to discuss about introduction to the MATLAB programming. My agenda is to make you clear how to use the MATLAB programming for all the application from the starting to the most of the applications like in the smart materials. There is no separate programming for the smart material itself, but whenever the smart material is applicable or the applied or adapt to a certain particular structure, so that that structure will work or that particular system will work as a very smart way. So these will based on various, it is varying according to the application point of view. So my application I already discussed in the previous yesterday's session. So majorly I applied for the plates as well as the beams. So these structures, once we adopt the smart material and then check its vibration characteristics and how to improve its vibration characteristics. And in addition to that, we have seen the applications of the smart material to the aerospace structures as well as our aerospace application, automobile applications, brakes and suspension systems and absorbers, dampers. So in this case also for a particular system, you need to develop the MATLAB code. And that's how these work with the MATLAB. So that's why basics of the MATLAB programming as well as how to apply these MATLAB to the vibration problems and normal simple numericals, how to solve it and how to use the loops in the MATLAB. So all these things are the interesting to the, particularly it is related to the smart material application. That's what we are going to emphasize today.
So screen sharing stopped.
Yes. Just a minute. Just a minute. There is some technical glitches there. Yeah, sorry for the inconvenience. Introduction to the MATLAB program. We'll see the first introduction part of the MATLAB programming, how to apply these MATLAB programming for solving the simple problems as well as the vibration related problems and some of the slide structures. So these are my aim today's agenda to go with the MATLAB programming. I hope all have you are with the equipped with the MATLAB programming, and maybe you can just initiate that one. The command window, you can start. So the MATLAB is a programming for doing numerical computations. And it originally starts with the matrix laboratory that developed this one. And these matrix laboratory, they took these initial, it became the MATLAB, and it have many built-in functions. So rather when compared with the C language, Python or the C++, it have a lot of built-in functions. So that's why it is very much useful for the doing or solving any engineering problems. So like data analysis also we can do in signal processing and optimization and several other scientific computations. So majorly here we can use the 2D and 3D graphs as well as animations also we can do, particularly by using the MATLAB. So once you start these MATLAB, you can see from the start window or your start view.
So your voice
You
is.
can, yeah, please, madam.
Can you make it voice clear, sir?
It's not clear.
Not clear, sir.
Now, madam.
Okay, sir. Mic a little bit far from your mouthpiece, a little far
Yeah,
from
yeah, yes, yes, yes. I just
your breathing is
kept in
coming.
reverse manner. That's why.
Yeah.
Yes, once you first start, open MATLAB. Either once you already starting using these MATLAB coding, definitely whatever the already existing uh, code is there, just I'll show you. I will just sharing a new thing. I'll say you see here. Uh, Directly you can any program which is made of the MATLAB will have the .m properties. Yeah, .m MATLAB. So this is the problem one. You can start directly. You can open this one by double clicking. So this is possible. And if you don't have like that way, just you can go to the start and then go for the search and go with the MATLAB. So directly from here also you can start. So just double clicking this one. Here also you can start like this with MATLAB. You can double click and you can start. So once we start this one, you can see there is a three windows will be appearing in the MATLAB. Yes, once you open this one, there is a, you can see here all the tabs which are related to the MATLAB. So here the new script, that is this script file that I will discuss later. And it is the new one, and open, you can open these script files and you can find the files, compare. So these all are the tab section, and here we have the home, then plot, apps. We can use various apps. So then basically you can see here the current folder, what is the history, it will show the history. and workspace, in which space we are working now. And this is a major window called the command window. So command window, you can keep anything here, like keep anything means you can start the coding. Normally we use is CLC. CLC is majorly used for the clearing all the things. If you want to clear all, then you can use a clear all. But once you use the clear CLC, that means everything will be clear. So these things we'll see in the next session. But now these about the three windows once we start or initiate with MATLAB. Then we'll go to our normal slide. So here, once you first open MATLAB, you can see the command window and workspace, history, and editor is nothing but the script file. So this script file will discuss further, and even you can use the shortcut called F5 also you can use. So that's what this older version of this one. Whatever I'm using is the 2017 version. And we have now 2019 also. So these are older version. It might be like 7 or something, 2007 or somewhere. So this is a command window, and this is the workspace or the current directory, and this is the command history. So here you can see the tabs are very less. Here you can see the tabs are very less. Now the very many tabs. And these are the major some of the useful commands called what they list all M files in the current directory, whatever directory you are using. The directory means the folder what you are using for this. Like now I kept the MLRIT, I kept as a folder. That file folder is nothing but a current directory. So list of all files in there, and type test. Once you use this type test, whatever these bold letters are there, these are the commands. These are the commands, and this is about the description of these commands. So what is a one command? dir means directory or is, and type test, what type of test we can do in this command window, and delete the test, and cd or the change directory. These are about the current directory, on which directory you are working. Sometimes you'll just start the programming, maybe you just open the one script file from some other folder, and we don't know exactly, and in the same time you may open some more m files or the script files from other directory or the from other folder. And once you start working on this one, even though the script file is open, but it may be taking the another folder. So in that case, you are running one code, but it will execute from the, or it will take the information from the another folder. So this way you will get some confusion. That's why show current directory. So which directory you are using, or which folder actually the program is picking the data, and that we can check from the PWD. And which test, which will give the display directory path, and which is closest, and who, that means how many variables are there, and what the data of these variables. And there is one more thing called the clear. Clear is nothing but all the variables will be cleared in the workspace, and CLC will clear all the command window. Even clear all also we can use to clear this. Clear all is majorly to vanish whatever the prehistory or the history. That's called space, it will clear. And whereas CLC will clear all the command window things. And you can also cross check whose name, size, bytes. So whatever is there. I checked this one in the previous time where A, B, C, these are the three variables I have used. So these three variables, size is 1, 1, 1, 1, 1, 1, and how many bytes it is occupying? 8 bytes, 8 bytes, 8 bytes. So the grand total is 3 elements using the 24 bytes, and it is all of the double arrays only. So whatever the variable you enter into the MATLAB coding, first it will take it as a one variable, and variable as a matrix only. It won't take anything non-matrix or scalar or the vector. It won't take like that way. It will always take whatever the variable you enter, it will take it as a one matrix. So it could be 1 comma 1 matrix or 1 comma 3 matrix or 1 comma 4 matrix, whatever it may be. But whereas other programs like C or the Python or somewhere, you have to mention whether it is a what is its size and all, and even you need to use some prefix things and all. But whereas here, no need to use any prefix. Directly the byte is there. How many bytes or how many memory, how much memory is being occupied by this? It is a 8 bytes memory. So all the matrix will be occupied by the 8 bytes. So the total will be 24 bytes. So in this particular program, we have a 3 variables. These 3 variables are size and then class this one. So always it is a double array only. And next thing is how to delete the variables from the workspace. So that's what we already seen. From the workspace, if you want to delete, we have to use the clear. And if you want to particularly delete some of the things, then A, B, we can delete. And whose the clear all means it will delete all the, or it will remove all the variables. But it doesn't mean that it will remove from the particular folder. It will remove from the only MATLAB execution. That's all. It won't delete the original files. The original files doesn't mean nothing to do with these commands. Then that's what I already seen discussed matrix. Always the MATLAB variables, all the variables as a matrices. So for our purpose, a matrix can be taught as an array. Then array means maybe you can say like a vector, and maybe you can take it as a scalar. So whatever it will always take it as a matrix. So then, what are these variable names? How we can give the naming or the name to the variable? The variable name is a case sensitive. So that means you know that a case sensitive means when capital letter and small letter, it is having a distinction. So capital A and small a is both are different in the MATLAB. Whereas other things, we will take A, B capital or the small letters, will take it as a normal high level languages. But whereas here, definitely this high level language will work with the case sensitivity only. And these variable names can contain up to 63 characteristics. So we can have a 63 characters in the 8-byte memory. We can use this name length max. So that is a 63 characters. It is the length of the, even it will take a single letter also as a variable name. That is also possible, but it should not be a number, but it should be only a letter. Variable names must start with a letter followed by a letters, digits, and underscores. So here I have shown you x equal to 1, x equal to 1, the percentage define the scalar variable x, and y is equal to 1, 2, 3, it is a row vector, and z 1 colon semicolon 2 semicolon 3. So these semicolon will distinguish this as a one particular row, and these also 2 is also another row, and 3 is also another row, and a is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and these are the list of the variables defined. So just we'll check these things by using a MATLAB. I'm going to the command window. Please, you all also go with the command window. Yes, this is the command window. So maybe just you can take it as x equal to 1. So here you can see I have not kept any semicolon here. Semicolon I have not kept here. Let us see if I keep the semicolon here. X equal to 1 and semicolon. So it won't show, it won't display anything. If you don't have any semicolon, then obviously so it is nothing but semicolon used for the stopping the results. And now we'll check with the matrix. y which is equal to sum 1, 2, 3. So then this is a one matrix. So it is a row vector, we can say. Same thing, z which is equal to 1, 2, 3, and 4, 5, 6, then 2, 7, 8. So these all are the matrix. This is how we can give a input into a MATLAB command window and get the output. So here also we have a many mathematical functions also that we'll see now. Is it clear? Have you practiced this one? Just I'm giving just some time. Before I'm just changing the slide, you can just follow this one. So now these are the variables what we have seen now. Then even you can ask the size also, size of the matrix. Let us say you just put a size size x. So then obviously it will show what is the size of these matrix. So that is also possible. Now just see, check here, size x or size z. So then it is a 3 by 3 matrix. So 3 indicates the rows, number of rows here, how many rows are available here. That's what we show here. These about the rows, number of rows. And then these about the these 3 indicate the number of columns. So we have a 3 columns and 3 rows. So 3 rows and 3 columns. So same thing. Let us say size x. So this is a 1 class 1. And all these things will occupy only a 8 bytes memory. And in the same way, you can check for the size y also. So then size y is the first one is a row and the second one is a column. So 1 row and 3 columns. So that's how the matrix or the initiation of any variable or naming of a variable you can cross. So this is about the variables. Then variable how we already seen this is the MATLAB prompt and it is a assigned operator, and by using these semicolon we can stop or suppress the command output. So these are like percentage symbol. So this percentage symbol normally we can use for the comment operator. So once this percentage symbol comes, after these whatever you have given, it won't be executed by the MATLAB. So till this point it will come, only it will execute till this point, and once this comes, and it will omit or it will exclude all these variables or all these data. So here now we can check only this part will be executed and only this part won't be executed here. So that's what the major thing from the percentage symbol. Then we can see the simple normal mathematical operation called plus sign addition and minus sign. So all these signs will work. Even the division we can use as a forward slash, whereas for the multiplication we'll always use the star mark. So a star 2 will indicate the a is a 12, so 24 is the product of this one, a star with, or multiplication of the 12 with the 2. So like this way we have the simple mathematical operation. So here you can check c is equal to a plus b. So where B is equal to 10, already we have given A is equal to 12. So C will be 22 and A is equal to 5. So here I don't want to get the results of this A 5. That's whereas B is equal to A by 2. So this is the forward slash which is used for the division purpose. So once we give the division, then we can get all the variables as a factors. So here after the digit, the fraction values will come as a 4 digits will come as a default. So default is a 4 digits. So whatever the results you give in the MATLAB, once it go for the fraction, then obviously it will go for the 4 digits. And if you want to increase the digits, number of digits, that also you can increase. And we'll see various symbols here. How to increase or decrease this one, we'll see the format thing in the later slides. So this is the prompt window, and these are the 3 dots which will indicate the continue the statement on the next line. Comma will indicate the separate statement and the data. And percentage we already see the start command with ends at the end of the line. Normally we'll use the at the end of the line we'll give this called the percentage, and the semicolon for the suppress output, as well as use it for the row separation also. That's what we have seen. The matrix, we can separate the rows by taking the semicolon, and colon, it will give the specific range. So what are the various ranges of a particular variable range from what is the starting and what is the end. So if you want to give how much stepwise it will increase, it has to go. So that also we can separate by using a colon. And these are the rational operators. We have the less than symbol, and less than or equal to we'll use like this way. Greater than or equal to. So that means once the less than symbol, then next you have to use the equal to, then it goes to less than or equal to. And equal to means it won't take it as a 1, it has to be as a double. So rational operator has to go with 1, whereas equal for the any one matrix or some variable name and then particular value. So there we can use only the single equal to, and not equal to we'll use this symbol. Then various mathematical assignment operators. These are called the assignment operators. Always the power will use the cap symbol and a dot with the cap symbol. So it indicates the, I already told, each variable will be considered for the MATLAB as a matrix. So if you put a dot and power, that means each element in that particular matrix will get the power. But let us say if we take the power, so it means only a few elements, or it is not a clear with this. So let us say if you don't have any matrix of more than 1 comma 1 size, then you can go with this symbol. And let us say if you have a more than 1 or 1 cross 1, if you more than 1, so in any place like column or the row, so you can go with the dot operator. So a dot, and it will indicate the matrix multiplication, and this will indicate the scalar multiplication or the scalar power. So this is the multiplication symbol, and same way for the matrix multiplication we'll use the dot operator, and whereas for the scalar we can use the normal multiplication. In the same way, division also will use the forward slash, and this forward slash with dot will indicate the division of a matrix, and backward slash it will indicate, it will give a operator called the or. So b by a, either it will take the 56 by 8 or 8 by 56, both are same in this case called the backward slash. So the addition, we can see here addition, subtraction, and assigning. This is called the assignment operator. Assignment operator nothing but a single equal to. Whereas the rational operator called equal to is a rational point of view. That means only comparison will use this one. So comparisons will make in the if you are following once the loops. In the normal purpose, we won't go with the rest. And MATLAB supports various logical operators also, not or this in. So both are same. The element wise are all are. This is about the logical and logical or, and that's what I told you. Majorly all these things are the logical and the law are used for the logical operators which are used in the MATLAB majorly. So logical functions, any, all, and here we can see XOR in the exclusive of all, and any return 1 if any element of the X is non-zero. All mean return 1 if all the elements of the X are the non-zeros. So this will return 1 at each nonce. So is infinity. So these are the infinities. Return 1 if the X is infinite, and the finite it will return to the 1 for each finite value. The find means it will find the indices and the values of the non-zero elements in the matrix. So some matrix function. Here these are the zeros. Once you keep the zeros, how many rows or how many columns you want? Like already we have seen Z value or Y value, be given the matrix size. So there, each element we have to specify what is its particular. Whereas once you keep the zeros and how many rows or how many columns are there, all things will take it. In this way, we can reduce the typing time. And it will go for the rows and columns, whatever you have given the things. All are the random. Or A and D, it will give the random values. So it will generate its own values in the matrix. So maybe you can give the ranges also. Then once it means all the rows and columns, you can make it as a all entries will be a 1. And I, it will the identity matrix. So it will go for the only the diagonal elements will be varying on the top and bottom side will be a same elements will be there. This is the identity matrix. So in this way, identity matrix 1 and then random numbers and zeros, no need to spend much time by using these functions or commands. You can assign directly some matrices. And then how to extract the submatrices. So submatrix are the nothing but a portion of the matrix that can be extracted and stored in a small matrix. So this is the major matrix which have a range here. That's what I told you here. Here also you can give the random numbers range, also you can give rows. So that's how I'm showing here. R1 and R. R1 will indicate the beginning and Rn will indicate the end rows, ending of the rows. So here you can give the particular numerical values. So those particular numerical values can be or this, that is a point of view. What I'm saying is a values if you are proper. Whereas here it is indicating we have a 3 by 3 matrix, let us say. Then in that case, I want to take only the 1, 2 only. And then here only 2, 3 only I will take. So like that way, some elements I will extract and then I will make another matrix. So here the colon will indicate, it means all the columns will be considered here. Only the rows will be varying. So here it will indicate only a here it will indicate a how many all the rows will be considered, only the columns which having a some specific thing. And here you can see the colon again. Here the colon is there. This colon indicate this is the beginning and this is the ending. So let us say 1 and 10. So in between dr will indicate how much spacing you need to make. So like let us say it is 1 and 10. Then in that case, maybe you can take 2. So then it will go with a first you will take the 1 and then 3, 5, 7, 9 like that way. So like this way we can give the steps also. For stepping only we'll use this colon symbol. I think it is clear. Yeah, now we'll see some example here. A 321 510 217. So this is about our matrix size. Here I didn't use the semicolon. That means the results will be displayed. So here the semicolon will distinguish the each row. So here you can see we have a 9 elements here, but whereas here the first 3 elements will come as a first row, and second 3 elements is a second row, and third elements will be a third row. So like this way it is a 3 by 3 matrix. The matrix size is a, we have a 3 by 3. So 3 by 3 matrix we have used here. So then access the element of a matrix called A12. So A12 means first row and second one. So what are the first row and second column? The first row is this one. 3, 2 is the first row, where the column is a second column. So our element we need is a 2. So element 2 has come. So like this way, if you want to recall or access the element of a matrix, that is possible. Even you can access here like A1 colon some 3, and then here you put the colon. So then obviously you can get some value. That's what here mean to 1 to 10. Have a small checkup with these. Just we go to the MATLAB command window. Are you able to see this MATLAB command window? So already we used the MATLAB code called MATLAB matrix is Z. So now I want to make some row or some element like Z 3 comma 2 comma. You can check here. Second row, third column is a 6. Then Z, maybe you can use, I'm using here the colon, comma, so what does it come now? It will come as a colon. I have used the colon means all the rows, 3 means it is the third column. So now it will come as a only a third column will come, all the rows will be there. So that's what this is the 3, 6. So even here we can change these things also, like Z, then 1, 3, comma 2. So then here my first row, third column, till third column I need, and sorry, first row to third row. I use that 2. The same way here now let us say Z 1 colon 2 colon 3 comma, it is a so all the only a 1 2. That means the gap is 3. So first row, and it won't take the second row, it will take the third row. So now you can check here 1 2 3 2 7 8. That's what is coming here 1 2 3 2 7 8. So we excluded the second row. So like this way, this Z 1 2 3, so it is a different row. Now I can assign certain value to this P, which is equal to Z 1 2 3 comma, then B matrix has become a 1 2 3 2 7 8. So this is a 2 rows and 3 columns. So like this way we can alter. I think, is it clear? Maybe just to take a small practice here.
Only in not organized, peak leaders, no
Is it clear? because it's a hands-on session. Please, if you have any doubt, you can stop me at any point and you can ask your doubt. You can clarify your doubts. Madam, any doubts from the participants? Please make a note of it, or you can convey to me. Then we'll go to our presentation. Just a minute. So now you can go with the B matrix also. You can do various number of things. And then here next is the operator called the colon operator. 1, 2, 10. So like this way also we can create various number of elements. So 1, starting from 1 and so like this way also, without any mentioning what is its variable name, just a numbers we can generate some numbers. And here 1, 10 is the maximum limit, lower limit is a 1 and maximum limit is the 10. And now we have the stepping is called the 2. So that means it will take the 1 and then it will go for the 3. It won't take the 2. And then again it will go for the 5 and it will go for the 7 and it will go for the 8, 9. So that's how it will take any other values. That's what we get. 1 to 10. Let us say you make 3, then it will take only 1, 4, then 7 and 10. So only the 4 digits will. Like that way we can use this operator. A operator 3, this means all the 3 columns, and 2 to 3. So that means the second column and third column only. Whereas here all the rows will be considered. So all the rows and the columns is only. So that's what will come as a 1, 7. So here this column indicates all the rows will come, only the second column will come. So you let us say you use this one, A colon comma colon. So the colon comma colon will indicate obviously all the values of A. Then how to manipulating these matrices? This is A or the superscript. If you give a some quote, single quote, then we'll go for a transpose of that particular matrix. Because I've already seen all the variables whatever we have assigned here in the MATLAB, all are taken as a matrices only. So here this is the A matrix, and in the superscript we kept a single quote, then it indicates the transpose of the particular matrix. And B star A, it indicates it's the multiplication of this matrix to this matrix. So matrix multiplication will occur, and even you can see there, this is a matrix multiplication. And this is a B star dot star. So that means element by element multiplication. So like A, B, then star dot star will indicate 3, 1 multiply, 2, 3 multiply, 1, 1 will multiply. And whereas this B star A, you already know that matrix multiplication. This first row will go with this one, and second row, like that way it will multiplication, normal matrix multiplication. And whereas this one is a element multiplication, element by element multiplication. The same way division of the things will happen. Again, the division of the element by element division also is possible. And here you can use these square brackets. These are nothing but a join the matrices horizontally. And B semicolon, this joined matrix vertically, it will join in the matrices. So these how it will work and all we'll see in the further in the next. Then these about the display formats. This is very important because already I shown. If you whether you use the format short or whatever it may be, normal 4 digits will come. So MATLAB will display any fraction value with a, this is a 350 by 7. So it will have take the 4 digits will here, and whereas if you want to go for the 14 decimal digits, this is for the format long. If you use this one format long, we can go for a 14 digits. And short e value, then e, it will give you the like a exponential point of view, then 5.01143 e plus 001. So these also one format. Here also again long e, where the 15 decimal digits also can go with it, but in the form of a decimal digits, the exponential form. Then in the same way g also we can use. These the best of 5 digits that is fixed on the floating points. This is 5.0143. So here you can see the best will be considered. So this will come as only the first digit will be. It is also a form of e exponential wave only. And here we can use the 15 digit fixed or the floating point. Sorry, this is 5.01 will come. Yes. Then the format bank, the 2 decimal digits will be only a 2 decimal digits. We can use the bank. In the same way, compact also we can use. They eliminate, it will eliminate the empty lines to allow the more lines with the information displayed on screen. And format loose, it adds the empty lines opposite to the compact. And one more thing, there is a round off functions here also there. Round off function, round x. So this will round to a nearest integer. So round the towards the 0. It will fix towards the 0, which is the near to the 0. That value it will. Then seal is the round towards the infinity. So it will go to the larger side. It will go to the opposite side. It won't go for the 0 side. It will go for the larger side. So same thing, 13 by 5. It will go for. So REM, it will indicate the remainder. So directly you can calculate the remainder of 14 by 3. So here the syntax is, it won't give any division symbol, only a comma will be used here. The next one is the floor x. This floor x towards minus infinity side it will go. And if you want to change the sign also, we can go with the sign. So which sign is used here? That's what it will show here. If written 1, if x is greater than 0, and minus 1 if it is written 0, let us say it is minus sign, then we'll go for the minus 1. Then 0 for the 0 value. These are the round off functions. Sorry, these are the round off functions. These are some other square root, log, cos, and a cos, sine, a sine, exponential, absolute, ABS means absolute, and sine, norm, sum, PROD, that means the product. And next one is for the plotting. The MATLAB will use the plot of one vector to the another one. So here you can use just a simple whatever you want to give. These two variables we need to mention here. Then even we can mention like this way also. And even you can plot only a single value. So here it will indicate two variables are there. Here it is a single variable, but the single variable is having some mathematical operation. Time plus I, and I is again multiplying with the distance. So there is a mathematical operation is there, and that also can be plotted. And even here I used a single variable called dist. DAST is a single variable, that also I can plot. Like that way, plot you can use for the n number of things. And here this one is the we have the first variable, second variable, and how my line characteristic. Maybe I want to use the color, I want to change the color of the line, and maybe a line style if you want to change. So all these things we can make it. The color means maybe you can put the colon, and then B means blue it will come, and maybe red color, different other colors, green color, yellow color, all these colors are there. Even we have a line styles also. And plot, hold and plot. So that means here I used the one plot, another plot, another plot. Like here now I plotted, let us say these three plots. One plot will come and it will go, and another plot will come and it will go, another plot will come. Let us say you plot all these plots in one time, then only you can get the last plot. So these plot only you can get, but whereas the another plots won't be appearing. So these two plots will not appear. But here, if let us say you use the hold command, then first will be then the first it will come here and it will hold, and then it will go here, and this will also come, and again next it will take this one. So like this way all the three plots will be coming in one single diagram of the single figure. So next one is the plot T D1 1C1 T D2. So like this way n number of elements also you can, or the n number of variables also you can use for plotting. And if you want to split these one into a several axes, so then we can use the subplot. Subplot, how many number of rows you want, how many number of columns you want, and how much is the place. So that also you can choose here. So like that way, subplot also you can use it. And then how to label it. X-axis we can label it, Y-axis we can label it, and even what is the title. Title you can keep as a title and bracket, then whatever you want in the single quote you can. And the legend. The legend is the it is used in the function only. Rather than labeling each time, we can use the legend here, so that X label, Y label will be there. If let us say Z is also there, and Z label also will be there. So those things we will see in the next slide. Take one example. We create an array of X element, and it's having a 100 samples, and we have a distinguishing or the separation called 0, 4 times pi and 100. This pi is nothing but a 22/7 symbol. So we can see here, this is about the X spacing. Y is a sine X, and now we can plot the Y. Now we can plot the Y. So maybe just we can take this line space, 4 by 100. So we'll check by running the code here. We'll go to the MATLAB command window. So now we came to the command window, CLC. So now you can check, only the screen is gone, everything has become empty. Now, but where the workspace is having still is having the data. Now this we can use it. NS B. That's is also one option here. Now anyway we don't need that one now. Y is there, Z is there. All these things we can use now also. Like let us say put Z, it will come. B, if you want to get the B, then you put a B. Then these are available. And if you want to remove all these things, then you have to use clear. Then no workspace, nothing is visible now. Only whatever is here we have used, and those things will be. So now everything gone, empty. So now line space 0. We used colon 4. Did we use the symbol? Just So this is about this thing. And if you want to see the results, you can line. It is the line space, not the line space. Here, line space. It automatically corrected this one. That's what is available. 10 onwards. These are the all the values of x. So once you use from 0 to 100, all these are the values. Now y is equal to sin x. So we don't need these results. Let's plot. Then you can see here we got the results in this. Everybody able to see this one? Is it visible? You can use the plot y, and same thing you can go with a plot x comma y. Use here, now you can see these numbers are varying because x are given, and so exactly it will come as a whatever the x is there, whereas the previous case it took as a default values, whereas here the x how much is varying exactly that much. So that is the difference with the plot with one variable and plot with the two variables. That's what I shown here in my slide also. Plot. So here I used the plot y. This is the plot x comma y. So x it took exactly the whatever the values, and here. So that's how. This will give the clarity in the behavior, and whereas here it will complete everything. It won't take the x into a particular way. Then, so then next we'll go for the plot with a same x line space y equal to sin x, y1 which is equal to exponential minus x by 3. Then obviously it will go downward. And here exponential positive value, then it will go upward. Then y2, I have taken the y multiplied with y1. So now you can check these one, and why it come as a error. Now we'll go for the command window. So command window here you can see here already I have taken the x value. So the x value we have and y value we have. Now y1 which is equal to exponential exponential of minus x by 3 minus x by 3. So minus x divided with 3. So I don't want these results. Now I got the y1 also. Now some z which is equal to y multiply with y1. So it won't occur because we can check here the inner matrix dimensions must agree. So now we can check the size. What is the size of size of y. Size of y is 1 row and 100 columns. And size of y1, it is a y1. Inner matrix dimensions must agree. Maybe the error using these the particular norm, we can go with a z, which is equal to y dot star then y1. Now it will multiply exactly. So now you know that matrix multiplication 1 comma 100 and 1 comma 100. Obviously, it won't be multiply with each other. These are matrix multiplication rule that is failed here. That's why I used the dot symbol so that element by element it will be multiplied, not by the matrix multiplication won't be possible. So it will indicate matrix multiplication, indicate the this element multiplication. So this element multiplication is possible, but whereas the matrix multiplication is not possible because the size is not agreeing. So 2 by 2 matrix can be multiplied with the 2 by 2 matrix. It can't be multiplied with a 2 by 2 matrix with a some 4 by 2 matrix or something. So like the same difficulty here we got it. I hope all are clear with this. I think. Is it clear? Any doubts? Now again we'll go for the slide in the introduction to the MATLAB, where we can use the next we'll go for the x1, y1 and y4, which is nothing but a this plot y4. Now let us say we plot the y4, then it will come like this way. Then whereas stem means each will come as a stems. And then y4 grid on. So now I have on the grid. So it will appear as a grids. So here is the normal plot and here is the grid on. So that means some grid is maybe it may not be much visible, but here you can observe slightly there is some grids are. So maybe we can change the grid sizes and all. Maybe this version I have more brightness. That's why grid is not appearing properly. Then this is about the how to use various loops. You can use the if statement, else if statement, else statement, and end statement. So even you can use the if else also. If you have the three conditions, then you can go with this. Even you can use the n number of conditions by taking a else if. Then it is a switch case otherwise and like this way the flow control loop conditions. Then loops point of view, for loop we have to the starting to the end point. Even we can have the steps also. Like while loop we can go with some particular condition but follow like a loop only. It won't go for conditional loops or conditional. These are the M files. Now we'll go for the script file. That's what here the script file is. The advantage with the script file is in the command window, whatever the things the script or the files you keep data, this can be, it can't be stored. Once you close the command window, so everything will go. But whereas the script file, you can save the data and you can keep the much of the data here. And whenever you want to retrieve and whenever you want to modify it, all the things are possible. It is just like a some normal Word file on the Word file or the Excel sheet, how we are using. In the same way, here the script files in the MATLAB can be used here. So then how to save this one? We can use the various commands and file name. This is a normal diary of. In this command, we can keep all the script file as a text. And then my mat file or my mat file, it will save the specific variables, whatever the variable if you want. That variable data itself can be stored. And SCI code, where it will save all the 16-digit ASCII format, and normally it is a dot .dat. So that SCI format is very much like if you want to run your MATLAB code results in a maybe some ANSYS or some other softwares, then we will go with a ASCII format, so that the import or export from the MATLAB to the some other softwares is very much easier. So whereas this one, these particular variables will be stored, and where the file names will be, all the text will be saved in the form of the test file. So these are about the various saving option. Normal saving option is you can generate one script file and you can keep a name and you can save it. So there is a general saving. These are about some special save, how to save. Now with these, the introduction part is over. Now we'll apply these to various particular things, how to apply. All these things we'll see by taking certain examples. So now we've taken the example one. Here the X array of 100 samples 1, 0 to 5, and then Y is equal to sin t and Y2 equal to t, and Y3 which is equal to t minus by factorial plus t5 5 factorial plus t7 by 7 factorial. How to plot all these results? By using a plot command, hold command, and line command. So this we'll see now here. And next we'll see the B. Next we'll see the B part. Now this plot command, T is equal to line space 0 to 5. I use the Y1 which is equal to sin t, Y2 equal to t, Y3 we already seen, and plot T, Y1, T, comma Y2, and these are Y1 is normally come with a black line or the blue line, whatever it may be, and then Y2 I have given a another color to here, dot line, and Y3 I have used the zeros. This is the symbol I have used here, and axis 0, 5, minus 1, 5. So 0, 5 means this is 0 and this is 5, x value, and y minus 1 to 5. So here I have given the how much variation also, and x label t, y label sin t approximation, and title is equal to sin t function. That's what the title has came here, and we given the x label as a t. This is the t label, and y label, this is about the y label sin t approximation. So these were the sin t, and text we have 3.5 0 sin t. This is about the text. So text whatever I want. Hello. Yeah, G text, it is a linear approximation, and G text which is equal to 4-term approximation. So these only the how the approximation is going on, but it won't be get displayed here. So these about the first in the plot command, and so here we have plotted 3 plots in the same plot command. Now by using a hold command, we can plot y1 separately, y2 separately, and y3 separately, and we can give hold off. So then hold on means first it will print this one, and then it will wait, hold on. So this will print y2, and then it will print y3, and then so once we say hold off, then everything will be displayed. So some participants have raised hand. Yeah, please raise your doubt.
Sir, hello, sir.
Yes.
Sir, actually, what is the main advantage of the MATLAB? Compare the Python and ANSYS software, and HyperMesh software also is there, sir. HyperMesh, everything plot is
Hmm.
coming now. So Python software
Hmm.
also mechanic testing, product testing, and
Hmm.
tensile, toughness, everything checking everything. Now everything plot is coming. So comparing that software, what is the main advantage, sir? I'm asking that question.
Okay. It is a very broader question yours, but anyway, I'll give individually each and every
Okay.
thing separately. Like
Okay.
first, I'll compare with Python,
Python.
C language, C++.
Yes.
So Python, C, and C++, it won't have any inbuilt functions.
Okay,
They
okay.
have, but very less number of inbuilt functions.
Okay.
Like same thing, let us say if you want to go for the matrix multiplication.
Okay.
Their simple example I can say as a now whatever you are giving here any variable, all the variables are in the form of a matrix only. But
Okay.
whereas if the same matrix if you want to give and scalar
Uh-huh.
if you want to give, there is a different formats are there.
Okay,
They
okay,
are
okay.
called format specifiers.
Okay.
Uh, like normal integer values are different and float
Okay.
values are different.
Okay, okay.
Then exponential values are different. So each thing you need a number of lines. Like simple example, if I take here, here I used the maybe approximately some 10 lines. If you want to
Okay.
solve this one by using C language or Python or something,
Yes,
definitely
yes.
you need to go with a minimum 50 lines.
Okay, sir. Okay.
That is the complexity to solve engineering problems is very high
Okay.
in the C
Yes.
language or all these things. But
Yes,
the
sir.
same way, that is the advantage also for that, because
Uh,
if you have the less inbuilt memory,
okay.
this can be used very easily and it can install very easily, and then we can operate the things very effectively, and even the
Uh,
internet applications and all is easier. So
okay,
this is
okay.
the first aspect.
Okay, sir. Okay.
uh, then is it clear, this one? Hello?
Sir. Tell me, sir.
uh,
Hello.
yeah, is it clear, that one?
Yes, sir.
Now
Yes,
we
sir.
are comparing these with the normal, it is engineering software, that is a non-engineering software, that the
Okay, okay.
difference between two.
And
And next we'll,
ductile compressive test, tensile test, everything test will be possible, sir. In MATLAB, everything plot is coming, huh?
all the plots you can get, but it is
Uh,
this is a numerical simulation, it is not a modeling software.
yes, yes.
This is
Actual
a
material will be deformation. So coming plots is coming, showing the practical will be showing how will be possible in the MATLAB only, sir. Possible.
no, they please understand this thing. This is a numerical simulation software,
Numerical sim.
MATLAB.
Okay.
If you give some equations, and if you give you can give it, so like you can predict how it can behave.
Okay.
So these also called the analysis or the numerical simulations.
Okay, sir. Okay.
That is possible here. Whereas now you are comparing these with the hypermesh or ANSYS software or Naston and Paston or
Workbench.
Star CD.
Nancy software workbench. Everything clause is coming. Yellow color, red color, everything showing.
Yes, that
Plus.
is a modeling software.
Yes, modeling
So
software.
modeling software is like a normal experiment. Now you are making
Yes,
certain experiment with
yes.
a
Yes.
real
Yes.
products or the materials. Then
Yes, sir.
how these material is changing. So
Okay.
those things are given by the MATLAB software, sorry, ANSYS software or Naston or Paston or
Uh,
Patron.
yes.
So like this Star CD even for the fluids and all CFD.
Yes.
That is it will replicate the real world, real things.
Mm.
Then
So,
each updation and all, they will go for the very near to the exact one or the real one. Maybe in the older versions, the material properties are not exactly given. So
okay.
there some results may have some more deviations.
Sir, I have
So
another doubt. Actually,
yeah.
in aerospace
Mm.
industry, flight will be going on air na in weather.
Mm.
So
Yes.
in weather
Mm.
also showing some yellow color, red color. Is the weather is not or good going flight? is a CFD and CFD software will be showing. Impossible to MATLAB also, sir. That
No,
whether
that is not possible. That is not possible.
not possible. Okay, okay.
What you can do with the MATLAB is you can make that model in a mathematical formulation.
Okay, okay.
Mathematical modeling you can write here. That
Okay.
mathematical modeling you can solve in n number of ways.
Yes. Okay, okay, okay. Thank you, sir. Thank you.
But whereas if you want to solve the same thing, you need to change particular property and then you have to run for a long time. But whereas
Okay.
here, if you just change one variable and you can get the results.
Okay, sir.
That is the difference. So finite element and finite difference also you can apply here, and all the finite things you can apply here.
Okay, sir. Okay, okay.
Okay.
Thank you, sir. Thank you so much, sir. Thank you.
Okay. Okay.
Thank you, sir.
Any other doubt? Yeah.
No, sir. No. No.
I think one more person also raised their hand. Is
Hello.
there any doubts? Hello.
Hello.
Yes, madam.
Sir, good afternoon. Myself,
Good
Dr.
afternoon.
Napinalata. So actually, I'm having one doubt, sir. This MATLAB is used to find out the optimum values, right, for various experimental results.
Yes, madam.
So whatever the optimum values, is it similar to with other software also, sir, like Taguchi? In Taguchi also we can do an optimum optimum analysis.
Madam, Taguchi is a method, madam. Taguchi is a method, and various optimization things also there. ANOVA, all these are the methods. Those methods can be implemented or can be brought here and solved. So that is possible. If the MATLAB is like a tool, we can use with this tool we can solve n number of
Other
types.
methods, sir, which gives the
No. Here you can what you can check in the MATLAB is you should not compare the MATLAB with the Taguchi method, because Taguchi method is having a optimization technique on that one. That is a one technique. So in the same way we have another techniques also. So we can compare that technique with this. But whereas the MATLAB will you can use this MATLAB for solving the Taguchi technique also, some other technique also, ANOVA techniques. These techniques also there.
the results whatever which gives the Taguchi, is it similar with this MATLAB, sir?
Yes, madam. Yes, definitely. Like Taguchi is nothing but like a one FEM method, or like just example kind of thing. FEM, you can use the FEM here. You can use the finite difference method also. We can use by using the MATLAB, but only the MATLAB is like you can use anything and it will solve it. Like it is just like a one piece of mic. You can talk or me, I can talk, whoever talk, but just like you or me, like a one different techniques. That's all. MATLAB is nothing to do with all these techniques, but it is a tool we can use n number of optimization techniques, and even I use it for the genetic algorithm technique for my research purpose. I use the genetic algorithm. Now I am working with some other optimization techniques, and then sperm bee optimization technique. So these all techniques also I am using only the MATLAB. Even MATLAB is having a separate platform called simulation. And for these optimization things also there. So for that it is more convenient way by using the MATLAB. Now in the updated versions is having more flexibility and more convenience.
So one more doubt, whatever
Yes,
the curve generated in MATLAB based on our data. So we have like first order, higher order, second order equation, like it gives, no, sir?
yes, madam.
So the values, whatever the x, y parameters are there, it gives a very clear solution, sir, how it is generated, like that information.
No, I am not clear. Can you repeat your question?
Yes, sir. Whatever the curve generated, it's a polynomial fit, like whether it a first
yes.
order, second order, any order.
Yes, yes.
The equation will be in terms of like x, y parameters, x, y.
Yes, yes.
X to the power of some value it
Yes,
gives.
yes. I got it.
That what is it gives any x values, sir?
No, no. You mean to
Directly
say
it
that?
gives that values, parameter values, or we need to solve by mathematical simulation methods?
Here, thing is where you are going to apply. It
Suppose,
is
because
is
suppose sometimes we need to derive whatever the generated curve is there, that in terms of mathematical model, we want to prove that curve is so and so order.
okay.
It
You
gives the
want to
clear
whether
information, sir, in that MATLAB.
no, MATLAB will use it, but thing is that if you don't have any that called a syntax error or any mathematical formulation, you have to make the first mathematical formulation. In that mathematical formulation, if you don't have any errors, definitely it will give you the exact result. Than with the
Okay.
same results, if you want to get by our human effort, maybe it may take some 5 days or 10 days, but it will show within 1 hour or half an hour time. Here the curve
Okay.
fitting, whatever you are saying, it is called nothing but a continuity. In the FEM will use this as a
Ah,
continuity, like second order
yes,
and
sir.
second order. If you want to have a continuity, then only the meshing is much possible. So the results will come in the smoother manner. These are nothing. These we call this as a continuity. In the continuity aspect,
Okay.
whether this continuity you have given properly or not. Like same thing, if you take the ANSYS, their mesh size,
Hmm.
whether your mesh size is proper or not, any intricate objects or the intricate space is there, this meshing is not done properly,
It won't give the solution. It
it
gives
won't give
some
the
syntax
solution.
error.
In the same
Yes.
way here, in the continuity,
Yes.
unless yours from your side, if it is very clear, then it will give 200% or 100% very good accurate results will come. So no issue in that. That is possible.
Okay. Thank you, sir.
Okay. Okay.
Thank you, sir.
Yes. Yes. Ma'am. Yeah.
Thank you, sir.
Any? Yes, madam. Yeah. Yeah. Thank you. Hello. Any other doubts? Or shall we continue with this topic? Hello, Gupta sir. Maybe it will take some half an hour time in the further. If you need any break, or shall we take, or shall we continue?
Sir, till 11:40 will continue, sir.
11:45, sir.
11:40, sir.
11:40. Okay, sir. Definitely. Yeah.
Then we'll wind up, sir.
Yes, sir. Definitely. Maybe it will take half an hour time. Or
Okay.
maybe they have some doubts, then maybe it may go some continue. Yes, so we'll take a little break and then after 10 minutes
Yeah.
we'll meet again.
Okay, sir. Okay.
Okay. Thank you.
Okay.
Thank you, sir. Welcome back. I think it's 10:40. I think shall we start?
Yes, sir.
Okay, thank you. Now we already started. We need to plot this y1, y2, y3, three plots, and by using a plot command, hold command, and line command. So we have seen here the plot command. Here, if you want to plot all the three, so in the plot itself, we need to mention all the three, and with a different color context. And whereas here it is a hold command where we can plot one separately and another one hold by starting hold on. We can start another plot and another plot. Like that way you can add n number of plots. And once you say hold off, then it will off. After that it will get displayed. So everything, all the plots will be mentioned into your. So then here by using the line command, where we can use here the line t y2, where here you can use the line style and marker style also. Even you can change the colors also. And X label, Y label, titles. So this way, these are the. And here you use the legend also, where sin t, the linear approximation, seventh order approximation, all. So then they use the functions for plotting xy data, there by ft cos t and x e power t and y is equal to 100 e power 3. So where there's 3t, where this t is varying from 0 to 2, and whereas here the ft is varying from 0 to 10. So in this case, you can use the line space and f plot x plot. So you can take curve in this manner. They given here the what are the limits. Then same thing by using a log and the grid. Here we can observe the grid and log graph. This is a log graph. So like this way we have exponential graphs, log graphs. So many graphs are available in the MATLAB. Those who want to explore these, you can go for and you can explore these. And next problem number 2, where this z is equal to 2xy square by x square plus y square, where the x is having a limit from -2 to 6 and 2 to 8. So here the program you can see here, x is equal to -2 to 6 and y is equal to 2 to 8. So sorry, here the typography error, it is y. So z is equal to, we have given this equation, and mesh and x label, y label, and surf, where this by using this surf we can keep here these effect, and x label, y label, z label. So here the x label you can see x axis, y axis, z axis, all these labels are okay. Like this way we can solve the any quadratic equations, cubical equations, all algebraic equations we can solve by using the whatever we are the preliminary knowledge we got. So then here it is a one vibration numerical, where we can solve an analytical expression for the response of an damped single degree of freedom system shown below. To give an initial displacement velocity is given by xt c e power minus zeta omega nt cos omega dt minus 5, where the c value and mass k and plot the response of the system using the MATLAB, omega and natural frequency, and damping ratio. Sorry, damping factor, and initial conditions, initial velocity. So This solution we can directly see from the script file, MATLAB script file. So here I can here omega and natural frequency clear all. So omega and natural frequency, zeta issue, and initial displacement, initial velocity. Here you can observe. Are you able to see this one? Here. So omega 1, zeta, x0, initial values, initial velocity, initial time, and delta time step, and the final time t. Here I used the for loop length of zeta, then response to the initial function. So omega d, the square root 1 minus zeta I square omega n, then x, the exponential form, and plot t comma x. Hold down. We need to run the code. That's why I kept the hold down, because many values will come here. And then title, the response to the initial excitation, x label ts and y label xt, and grid I given the legend as a xt ts. So we can run this code here. While running, we can run directly like this way, or otherwise you select this thing and then you can run. That is also possible. Yes, here xt and ts. Here you can see the grid. Are you able to see this plot? So these are the plots. We have, this is the mean time, yellow color one. So xt label, and it is the title labels, and this is the legend, and x label, y label, and the legend is given. So like this way we can use the for loop. Now in the same line, sorry, we can see some more problems. Already problem 2 we have seen. Problem 3 is a, I have not mentioned there. It is a matrix, A matrix, B matrix, and addition of the matrix, multiplication of the matrix. Here the multiplication of the matrix is happened because it is a 3 by 3 matrix, and it is also a 3 by 3 matrix. A is a 3 by 3 matrix and B is also a 3 by 3 matrix. That's why we can able to make these D, which is a multiplication of it. And A square, you know that A multiplication with A, and A transpose, and this is the A transpose. And then here you can see the B transpose, and then A transpose. So both you can use here. So then J, which is equal to A square plus B square minus A multiplied with B, and det A, determinant of A, determinant of B, and determinant of A star B, and where I is equal to E plus B star B minus D. Whereas it is a 3 by 3 matrix, all the multiplication will lead to a 3 by 3 matrix. So multiplication and additions and all everything will be very easy here, and you can make many. So rather you can select all the things and then run the code. You can see the result in this. Result in the command window. That's why I'm going to command window. So here A answer 12. So here you can see all the workspace and answer, and 756 where I is equal to, it is a determinant, two determinants, and it is the multiplications and additions. So these about the I. So like this way we can solve the matrix problems. And next we will see one more problem with the algebraic equation. So here, if you want to find out the eigenvalues and the eigenvectors of A matrix, then we need a eigenvalues. Then we can find like EIG eigenvalues. We can find the roots also for this particular equation. Like it is an algebraic equation. These algebraic equation we can find the roots also. And for loop we can use the plot the free vibration response of the masses M1 and M2. And these from the SSRAW 5.3 and recent fifth edition of the SSRAW. And I1 to 501 TI X1 where X2 we can use the subplots. So like this way we can solve. I think you can see here eigenvalues. These are the eigenvalues. These are the V and eigenvalues. We got the two eigenvalues, 1, 3. As eigenvalues and the eigenvector 1, 2, and 0. So first one is the 1 and then next one is the 3. So like this way we can solve the various vibration problems. So then roots also we can find this equation. Roots of a quadratic equation. Where we have to use this one and solve this one. Roots of x. Then plot. Here we can plot this one. So this is unbalanced. So then problem number 5, where we can matrix A, B, D, E, F, and then the force equilibrium thing of frequencies, and then the solution for the structural variables, and various colors I used is line length and all, moment equilibrium, and these greatest common factor, you can position, and all these things we can solve by using a solve the frequency 1, frequency 2, frequency 3. Moment equilibrium, I think it is a force equilibrium, These one, and these the engineering mechanics one numerical. So these few examples just I would like to show. I have worked in a long time. Then we'll see the next is the second problem. So the second problem, for the system with arbitrary viscous damping, the response must be obtained in the state space, which implies the use of the transition matrix. The response to be evaluated on a computer, then the state equation must be transformed to the discrete type, determine the free vibration response of a 2-degree of freedom system, free 2-degree of freedom damped system with initial conditions are 0, 0, 0.01, and x0 is equal to 0, 0. Force is equal to f naught exponential e power minus alpha t acts on the system. Find the forced vibration response using the MATLAB program. So these are the transient response numerical. This one, mass and the stiffness matrix is there. All the 4x4 matrix. So we'll see how to solve this one. So your mass value is given Ka and C value F naught alpha, and mass matrix is there and stiffness matrix is there. Z here we found the eigen values, and conjunction of these V and a transpose, then square root of this one, then convolution integral solution. We got these F value as well as PA value, and the solution for this model coordinates and responses. We got X label, these graphs also. Either now you can see all the program is completely, there is no separation is there. Either you can run this one or you can go with a selection and then run the selected one. So both are possible here. So here x1, x2. So we plotted both. And if you see the solution, we got response, the solution of the model coordinates, and which values you want to display. Those values, maybe you can remove the semicolon and then those values will be displayed. While if you want to check your MATLAB code whether it is working or not, these things also, just by using semicolon, using and removing the semicolon, you can check whether this particular step is being executed or not. So like this way I have given a small idea or a brief idea about what are the fundamentals and how to solve various problems by using the MATLAB. With this knowledge you can practice more, and for a particular honeycomb or a smart material, and if it is being fixed with some sort of the structure, and you can make your own mathematical formulation, and these mathematical formulation you can run by using the MATLAB, or whatever the structure you have taken, if it is feasible and can be modeled in the ANSYS or any SolidWorks or maybe Abacus. So then you can model there also and you can solve it. And those results you can check with the MATLAB results, or you can check these with the experimental results, or all the three also you can do it. So like this way you can do some research work in the various smart materials, or frankly we can say this as a smart structures. So these only the like are the basic idea I have given to solve the quadratic equation, some very few vibration problems, and some of the engineering mechanics problems. Just I have shown because these are not drafted for these one. These are available from my previous workshops or presentations from there. So I think with these I concluding the session, and I hope you thoroughly enjoyed this session and got some good knowledge on this MATLAB and how to use this MATLAB for the various particular vibration problems or structural things, and the structural integration of these smart material with various structure so that it become a smart structure. So if you have some doubts in these, definitely you can always contact me. I'm sharing my contact details already. Yesterday I shared my details, and you can follow them. So you can contact my mail ID. So if you have any doubt and all, definitely you can whatever the possible I can help you. So this is what I shared my contact details in the chat box. Okay. With this, I'm stopping the session. If you have any doubts. If you have any doubts, you can raise. Just wait for a few minutes. Yeah, Gupta sir. I think there is no doubts from the audience.
Yes, sir. Okay, and if no doubts, we'll wind up, sir.
Okay. Sir.
Thank you for such a nice session, sir.
Thank you.
And behalf of MLRIT, and any doubts participant they can ask. Otherwise, we'll wind up the session.
Yes, sir. I think I hope no doubts. I feel. With this, I am thanking the
So thank you, sir.
MLRIT management and especially HOD Gupta sir and Srikanth sir and madam for organizing this session and calling me for delivering these guest FDP. Yeah, thank you very much, sir.